All right, thanks everybody.
Now, thanks everybody, and welcome to today's webinar, Build Your Simulation IQ. My name is Marwan Azzam, and with me is Dean Rose. Dean is going to talk about Helius Composite case study demo today. He's going to go through a few sample runs here to compare the results and walk us through how we would do that. And happy Veterans Day, everyone. Dean is on the left here. I'm on the right. If you're looking at the picture, the fish is no longer with us, by the way. So Dean, please go ahead.
All right, thanks Marwan. And I want to appreciate everybody for hanging on. We had some technical difficulties, of course, right before we got this kicked off. So glad everyone stuck around. We're going to have a great presentation. I got a few things to cover before we get started. These are just some things that have kind of been going on, and I'm not sure of the audience that we have, but I thought I would cover first and foremost the most recent update for Helius Composite. It's named Hotfix 1, and it contains a few fixes and some improvements to some new functionality that we added to Helius Composite 2016. That can be added through the Autodesk Application Manager, or you can download it directly. So a few options there if you're a Helius Composite user and you're looking to get those updates. Secondly, I wanted to throw in an update announcement for Helius PFA. This is the FEA add-in. I'm not sure if anyone on the call is using that or familiar, but I just wanted to let everybody know that that is available. It contains some new functionality and some new bug fixes, so that's available for download. Same method can be downloaded through the Autodesk Application Manager, and there is a link down here at the bottom, and you can go here, you can download this document, and you can see I have some hyperlinks here to more information. Jumps to the documentation where the downloads live. So you can get all the information you need there to stay current. And then lastly, I just wanted to mention something that we're all working on here at Autodesk Simulation, and this is called simhub.autodesk.com, and it contains a ton of information related to things that are going on, current events. There's an events page for these webinars for Build Your Simulation IQ. There's also some announcements for AU. You'll see when you log in, one of the people that does a lot of the Moldflow webinars, Kate Choppett, she's front and center on that page right now, talking about some work that she's doing for Autodesk. So I invite everybody to check that out and see what's going on at Autodesk Simulation. All right, so today's agenda, just to let everybody know what we're going to be covering. Going to walk through the Autodesk Application Manager, just show everyone what that is all about, since we get a lot of questions on how do people update the software, and since this is kind of a troubleshooting and going over common cases that Autodesk support people get, this is one of the things that I wanted to highlight. So I'll go through that quickly and just show everyone what that looks like so you know what to expect, and if you have any issues you can always reach out to us. And then the majority of our presentation is going to be walking through just a very generic Helius Composite case study, and it's just going to demonstrate how easy the software is to use, some of the functionality that's available, and just like Lionel Richie says, it's easy like Sunday morning. So let's get started with the Autodesk Application Manager. This tool comes with all the Autodesk products, and it kind of runs in the background. You'll see it in your tray icon section. You can open that up, and this image on the right is what that looks like. And it'll show you all of your pending updates as well as your update history. So it's a great way to check and see where you're at as far as what installations are available. Here you can see demonstrating that the Helius Composite 2016 Hotfix 1. I have installed that. It gives me some indication of that. It also gives some severity, so we included a lot of fixes, especially for the new bolted composite tool that we have. We did some updates there based on some customer feedback, so it's a great place to look, and you can see, if an update is that important for you. And it also gives you a direct link so you can go to the documentation and see details about that update. So, if Marwan is on the call, if he's interested in, do I need to update this today? You can click on the details. It'll take him to the documentation page, and he can read through all the fixes and any known issues that we have. So it's just a great tool there, and it should run in the background, but you can open it up and look through and make sure that you're up to date. So
yeah, it's done in the system tray. That's where you access it from.
Yep. So yeah, I think, and if you have any issues, ever updating your software, feel free to contact support. You can reach out to myself or Marwan. We're always helping, customers that have, other questions, and we try to make sure everyone's updated. So feel free to mention that if you ever work with us and support, and we will get you pointed in the right direction. All right, so today we're going to be doing a live demonstration of Helius Composite 2016, and we're going to be doing a stiffness case study. We're going to be doing some stiffness comparison, looking at deflections with a variety of different layups and materials. So just again demonstrating how easily the software can be used to create different configurations of composite layups, and how those results can be obtained, and then how you can copy and paste those, put those in Excel, and just kind of build a matrix to look at some comparisons of different materials. So the common features we're going to be using today are the new laminate. We're going to be looking at some of those properties. The sandwich module is a tool that we can use to create sandwiched composites, as well as the two beam module. So these are probably some of the more common features and most common questions we get, how to do things. So this was a pretty good case study, I think. All right, so for the materials that we're using today, we're just going to be using default materials that come with Helius Composite. You can manipulate what we are going to do today. You can create your own materials. You can use other default materials that we have. I just wanted to keep it simple so people can follow along at home and recreate what we're doing. I'll be using the T700 carbon epoxy laminate. Also be using an aluminum honeycomb core, and I'll be using the aluminum 6061 T6 material that is also included. That's an isotropic material. So we're going to be doing a simply supported point load for a plate, and I'll be able to show more of that when we go through the demo. So just some information about what we're going to be comparing. We're going to be doing our base laminate is going to be a 0-90-90, so that's a 0 degree orientation, 90 degree orientation, 90 degree orientation with a test core that we're using, and then a symmetric layup on the other side. So we're going to start with this base laminate. We're going to rotate it 90 degrees, show you guys how to do that, and then we're going to rotate 45 degrees. And along the way, we're going to be looking at output and see how that changes based on these different configurations. And then we'll be looking at a second layup, 0, 90, and then a plus or minus 45 with the core. And lastly, I threw in another example, and that would just be the same aluminum core with just a aluminum skin on it. And then we'll just be looking at a flat aluminum plate and comparing all those results, doing some weight comparisons with the output that we get. So that should be fun. All right, and we'll jump into the live demonstration here. Just move this over here. All right, so here I have Helius Composite 2016 open. I'm sure most of you are familiar with this. We'll go ahead and get started. One thing I want to show is we can open up some of the laminas and we can see our 6061 T6 aluminum. We can open that up, get a good visual indication of what these properties are, stiffnesses, Poissons. If we ever want to, say, modify one of these for maybe a slightly different aluminum, we can go ahead, modify this value and save this as a new aluminum material. So while we don't have all the aluminum materials, this is just a great jumping off point. We kind of give you a good base to start with, and you can build from there. So we also have the T700 epoxy, and same thing here. We can open this up and take a look at all the material properties. And so for today, we'll be building a sandwich panel. So we'll go to the sandwich analysis. And like I mentioned in the PowerPoint, we're going to build a laminate sequence, and we're going to be looking at the top face sheet of the material. So we'll go ahead and select Add. This will populate a field where we can enter our lamina, and we can select our T700 epoxy. And by default, it comes with the thickness specified. We can change this if we have a different material, but we'll leave it as it is. And then we specify the angle of orientation. So here we're going to specify a 0 degree. And we can go ahead, if we want, we can select Add, create a new one, or the easiest method is to just highlight this by selecting this box with the arrow in it. This highlights the entire field, and then we can just select Repeat. And then we can change the fields that we need to. So we only need to change the angle here. And so that's a really fast way of creating multiple plies. You don't have to go back through and select the material. And so we can do 0, 90, 90. Another thing we don't really need today, but we could actually select all three of these and create a symmetric layup. So it'll highlight these three fields that are selected will be laid up in a symmetric format. So you'll have your 0, 90, 90, 90, 90, 0. So if you're doing a stack sequence with 40 or 50 plies, I'm sure all of you know how tedious that can be. So this is a great way to speed that process up. So I've gone ahead and created a few materials. So that's one of the benefits of having Helius Composite is, we can create these and then store them so we can go back and use them again later. So I've created case study 1, and here we have T700, and we have our 0, 90, 90. So really fast, fast way to jump into those. So now we're going to define our plate dimensions. So I'm going to use a 220 millimeter wide plate and 325 millimeter length. So the width is in the y coordinate and the length is in the x coordinate. And TC is the core thickness. And if you're ever curious about what any of these annotations mean, some of these are spelled out a little more clearly than others, but you can always go to the online documentation and look at the sandwich analysis section, and there will actually be some definitions in there. So it's a great place to look if you're curious about what they mean or you want a little more information about how those are defined. So We're going to do a 1.2 millimeter core thickness. And this is the core type that I was using for all my other analyses. So next, we're just working left to right. So we start by defining our lamina. We move to the sandwich geometry tab and define those dimensions. And then we move to the beam bending. So here we see our boundary conditions and our load conditions. Gives a good graphic representation of what you select here. So we have quite a few options. Those are predefined, but we have quite a few, so should be enough to cover a variety of configurations. So we're going to define our load. So we're going to do a 100 Newton load and select calculate. It's very fast, and we're given a lot of output. So we're able to see our inputs here and make sure that the software, being in a support role and previously in a QA role, one of the things I like to see is that my inputs that I'm adding along the way are being read correctly and being regurgitated to me. So that gives me a pretty good confidence that I'm on the right path. So we also get some weight information. And then for intents and purposes today, we're looking for these deflection values. So we have a 33.41 millimeters of deflection. This is from just bending response. And then this total deflection would be from the combination of bending and transverse shear response. So here we can see that I have a spreadsheet with some information, and I'll pull that up while we're talking. Is there anything you see, Marwan?
No, it all looks good. Now, when you define those laminates, of course, and you define the core in the next step, it assumes that those laminates are repeated on the other side of the core.
Yes, we're assuming that it's symmetric. So if you have, this is a question that we've gotten from customers before, they have a composite, a sequence on one side and a slightly different sequence on the other side. And that would be a limitation of the current tool. We assume that they're the same and symmetric. So if you have a scenario where they're different, this tool would not be able to resolve that. So if you do encounter that situation, feel free to reach out to us. You can also jump on the Idea Station forums and post a question or just a comment, and the product team takes a look at those, and they'd be glad to see if that's something that users are looking for. So that's a good point.
Mm-hmm.
All right, so here's just a spreadsheet that I started populating with some of the output. You can see that I've already filled it out most of the way. But you can see here 33.458. What you can do, you can just highlight that, do a Control-C, go to your Word document or your Excel, and you can just copy and paste that right in there. So that's really nice. We also have an Add to Report tool. So by using this Add to Report tool, it actually records the laminate that you use, the geometry, the beam bending, and so on and so forth. It puts that all into a document, and you can create a PDF from that. You can also modify what's included in there. So that's a really cool tool as well. I won't be using that for today since we're just going to be looking at a few bullet points on the results. So next, we want to look at, we have this no rotation configuration, and then we want to rotate this entire specimen 90 degrees. So there's an easy way to do that. and we can go back to the laminate tab, and we can see here, I'll blow this up so everyone can see, we have ply 1, and this is a 0-degree orientation. It's visually demonstrated by the lines. And then we have plies 2 and 3, which are 90-degree, and we can also see that those are indicated there. So if we want to rotate the entire specimen by 90 degrees, we go to this rotate laminate by degree field, enter 90, and select apply. We can see that the fields in the ply stack up sequence are changed, as well as the graphical representation. So this is something that's new for 2016. Pretty cool that you can kind of see this on the fly. We can rotate it around, kind of get an idea of what we're looking at. This comes into play, as a more convenient tool as you increase the number of plies in your stack sequence. So as you have 12 or 20, this can give you a good indication of thicknesses, orientations, and help you catch any mistakes that you might make on the way. For instance, if you entered 150, we can see here that there's an indication that one of these laminates is much thicker than the other. So if I was to look at this, I'd say, yeah, something doesn't look right here. I can start looking at my inputs and see that I've inputted an incorrect value, and that happens more often than we'd like. So we've rotated this by 90 degrees, and now we can go back to our beam bending, select calculate, and we can see that these deflections change. And they're, as we can see by this spreadsheet, the values are quite a bit different depending on the orientation of this material combined with the geometry. So it's one of the things that, having a composite material, you can custom tailor it to meet what you're looking for. So really good tool, very fast, very efficient. And then if we want to rotate it by, say, 45 degrees, hit apply, we're back to our original configuration. Input 45. And so this adjusts all the plies by 45 degrees. We can go back, hit calculate, and we can see the resulting deflection. So it's just a very quick way of iterating between different configurations. And then next, if you wanted to vary the core thickness, we can go in here, change the core thickness, leave all the other dimensions the same, go back to our beam bending, and bam, we have our new deflection. So not only can we change the configuration of the plies, we can also change the core thickness relatively easily. Here we have, 4 different combinations of the same material and a vast difference in response. So very quick and easy to do. And next we'll look at the second configuration that we have in our case study. And this is a 4-ply 090 plus or minus 45. We have the same thicknesses. We'll go back to our original 1.2 millimeter core thickness.
Hey, Dean.
And again, yeah.
This is Kate. I just wanted to I thought now might be a good time. There were a couple questions that came in.
Oh, sure.
The one question from Matthew Summers was, what programs can export into Helius Composites? I think this was referring to what you were previously showing.
Let's see, what programs can export into Helius Composite? So I'm assuming that this question is in reference to materials, possibly. And I'll kind of go through the materials need to be created in here we don't read in any external materials, but we do have the ability to create materials and export to some FEA packages, and we can do that through the export material. So while we don't have the ability to import materials, we can certainly create a material and export those values to something that can be read by Abacus, ANSYS, Simulation Mechanical, and Nastran. So some options there. As far as reading in geometry and things like that, we don't have that capability yet. That's something we've kind of been toying with as a future development. So certainly some discussion being done on that. So I hope that answered your question, Matthew, on as far as what programs can export into.
Okay. Got a couple more rolling in if now's an okay time. How does an epoxy with no fiber content have definable orientation? What is the angle referring to in this case?
So for that instance where you'd have, say, like an isotropic material, like a core material or an aluminum, which I can pull up here while we're just doing some discovery. We can see that the aluminum, the E1, E22 stiffnesses are the same. So this angle of orientation, because this is a composite tool and that's kind of the intended focus, this 0-degree angle orientation is just kind of arbitrary. So I mean, we could essentially put this at 90, we would get the same response. So if you have a material like that, the angle of orientation is not really I don't want to say useful, but it doesn't really indicate anything since it's an isotropic material.
It's irrelevant, basically. Could be
Correct.
anything.
Yep.
All right, and that question was from Eric Henry. And then Matthew Summers asked, can Revit and Inventor export into this program?
Yeah, and I think we kind of covered that before. And at this time, we don't have that capability, but there was I believe it was a beta of some software that we had. I'm not sure that's available anymore. But certainly if there's something you'd like to see that you think Helius Composite can address, certainly jump on the idea station and just post some pictures or some information about what you're trying to do, the workflow that you have, and something that, the results that you'd like to see. And the product teams will definitely see that and take it under advisement. So those are really good questions. And I invite anybody for, if you're familiar with this product or any other products, the Idea Station forums for each product are a great way to throw ideas out for things that you would like to see but don't currently have.
And I'm going to go ahead and post that actually into the questions, so everybody has a link for the Idea Station too. So
Another question here, Dean, is can you explain how you can predict engineering properties of sandwich, e.g. shear modulus, biaxial form, biaxial construction?
Yeah, I think this is from Amir. I think I'm familiar.
That's right.
We have some different configurations that you can use. One of the things I've actually been looking at is if you have, and I may have to follow up with Amir after this for this particular question.
Sure.
Maybe a little more in depth, but there are some ways. Yeah, we'll follow up on that later. I'm not not quite sure how to address that one just yet. And I'll think about that as we go through this, and maybe we'll get to that at the end. So,
Another question is, wonder if Helios could calculate beam deflection for columns and, I'm not sure, that's a misspell, steel beams or shell beams? I'm not sure which one it is. It says steel beams. But again, wonder if Helios could calculate beam deflection for columns and steel beams. Okay.
Yep. Yeah, and you can. We have the beam bending, and this is just for sandwich composites. We also have the two beam module here, and we'll jump into this real quick. You can define the same laminate and then specify some geometry. So we have a number of predefined geometries. You can select that. Select your geometry that you know is called out in the drawing, and you can do bending. You can also do column stability, cylinder stability. So there's quite a few different configurations. Some vibration response, torsion, and so along with that, you can set some eye section and define your material. So pretty cool. The one limitation I have to say is that it's confined to these predefined cross sections. So for some instances, you may be using something that is just outside of the scope of this. Maybe something that's more valid for an FEA tool or something like that. So we try to cover a wide gamut of things for closed form solutions. So there's certainly quite a few scenarios that become too complicated for a tool like this, and that may be something for further discussion for improvement, added functionality. If there's a cross section that you'd like to see that you use all the time, let us know and we can look to add that in there. So we also have a pressure vessel tool, so you can define your radius, and this allows us to do some pressure vessel calculations, and so we can apply an internal pressure and get some response for that. So pretty cool. And I think just to stay on course here, get back. I think we got a little distracted, and I'll try to wrap up what I have for now. And then again, Amir, I'll get back to you. Marwan and I might follow up with you after this. We'll have a quick call and discuss more about your questions. So maybe look to throw that in a future webinar. And so I went through case study 1, case study 2, very similar, just a slightly different scenario. We can see here, we'll do 90 degree. We can see again that these are all rotating together. We'll use the same core thickness. And again, we can calculate this. And so what I've done here, just kind of jumping ahead, I don't think we need to go through every scenario for people. We have the 0, 90, 90 face sheet, 0, 90 plus or minus 45. Based on this weight output, we get it in newtons. We can convert that to earth mass and get some output that we can compare here. This particular sample weighs 105.9 grams, and then we can see as we add more layers, it gets more weight, obviously. We change the material to aluminum, we get slightly heavier, and then if we don't have any core material, as I'm sure a lot of us would expect, the weight goes up significantly. So we can see just a little bit of the output deflections. For this particular scenario, maybe all of these are fine as far as deflections. Maybe there's a specific scenario where 15 millimeters is the maximum allowed deflection. For this scenario, I was thinking about a panel that fits over an engine bay. Having a minimum amount of deflection in there prevents the panel from actually rubbing against any portions of the engine that might fray or wear through the panel, or the panel may actually fray and damage some of the lines, hydraulic lines or air lines, things like that. So there may be a requirement here. I was just looking at minimum deflections and just kind of doing a comparison of weight, so you can kind of see that for yourself. And then here is the second layout where I slightly increase the core thickness, and we can see the effects on the maximum deflection as well as the weight. So jump back to the PowerPoint. So, and this is just demonstrating some common questions that we've gotten over the past few months on how to quickly create a laminate, change the laminate configuration, and get some of those outputs, so we can do kind of a quick case study and comparison of those different configurations. So I just demonstrated how simple this can be, how quick the calculations are. So we're not waiting on significant analysis to run multiple times. As you go through this, there's some of our customers are doing this for 20 or 30 different configurations. So you can see how doing it quickly can save a lot of time. And then the reporting functionality that you have, we like to keep it as simple as possible. So we've added this reporting tool. You'll see the report button in a few different areas, for pressure vessel, for torsion results, bending results. Any of these results that you get, you can add this to the report, and it'll be available in this in this report manager. So just a pretty cool tool. And then you can also go back to outputting like we did to an Excel spreadsheet, and that allows you to manipulate those values a little further if you need to. So just a few things that have come up over the last few months. So see if I have anything else. It looks like it's about it for today. Marwan, did you have any additional notes as far as I know Marwan is new to the simulation composite team, but he's an old veteran from the Al Gore simulation mechanical days. So some of you on the call may be familiar with him from working with another product. So he's a valuable asset.
Thank you, Dean. No, that was a very good presentation, Dean. I mean, it shows us how simple the setup is. You can do so many different configurations in not a whole lot of time, and as you can see, get pretty diverse results by basically working with the same raw material, so to speak, the same layers, just lay them out differently, and you get such different deflections. In this case, we're looking at stresses. And you can choose which one based on your application is the most suitable, which may not always be the one with the least deflection. You want something that deflects a little more. So you can make a table like that and compare and pick which one is the one to go with in a short period of time. And of course, there's a ton of materials out there, and the possibilities are infinite, so you can create your own inside of Helius.
Yeah, and I think we just had one more question from Amir. We'll try to get to this one. We're kind of wrapping up towards the end of the hour. But as far as the lamina inputs, we have a couple options. We can create a new lamina and just directly input your stiffness moduli, E11, E22, E33, your shear modulus values, Poisson's ratios, and then our strengths down here. So one of the questions we get a lot, and I know it's really frustrating, is, customers get a data sheet from a manufacturer and we have E11, maybe E22, and G12, and customers ask, well, what are the rest of these values? And that's a really challenging question, and we're working on ways to provide better answers for customers to get those inputs because they're not readily available, and a lot of people just don't have the capability of doing their own material testing. So if you are looking for additional material properties, I invite you to investigate academic research papers to supplement manufacturer data sheets. There's also a variety of websites out there where you can get additional material data. So that is one question we get routinely, is just, how do we calculate these values? And we have to kind of say there are ways to estimate these values and kind of rules that we can use, but at the end of the day, each user has to use their own set of principles and their own engineering judgment to make sure that it's sound and reasonable. So, and then the second option, new lamina, we can also create a new lamina for micromechanics. So here we have our fiber matrix. We define the fiber content, and then we use our own micromechanics model, and we come up with these material properties based on that. So there's some information on kind of how we do that. So there's two options there. If you know the fiber and matrix properties, this is a great way to do that, to get that lamina.
Yeah, another point, and correct me if I'm wrong, Dean, even if you don't have this, the most accurate properties, it might, your results, if you're trying to compare different layups, it might still be very valid just from the comparison point of view.
Yeah, definitely, and that's something, sometimes people come in and they say, well, I've got a material that's very similar, we try to list the most common materials, but someone may use, a material that's newer that we don't have in our database. You can open up IM79773. Say this E11 value is slightly higher, but the other values look the same. This is as I mentioned early on, this is a great starting point. You can actually go in and modify this and say, I want 1.8 e to the 5, and I can save this as Dean. And so now I have my own material with my properties in here, and I can play with this, put it in some different load configurations, and if I don't know some of these values, I can take a look and see, does this one have a significant impact on the configuration that I'm using? Sometimes you may see that, one of these values doesn't have a significant impact, so, maybe good enough for what you're doing. So, all right. So, I think we've got a few questions about trying to download, trying to get to the YouTube link, and Kate's sending out some information on that.
Mm-hmm.
And we'll make sure to get that link updated as well, so everybody has access. The PowerPoint isn't in there yet, so and I'll try to add the PowerPoint and the Excel spreadsheet, you can just have those values to kind of see what mistakes I did along the way. I'm sure it's not perfect, but yeah, feel free to point that out and let me know what you think about this presentation. So I think for now we will wrap things up unless there's any more questions.
Nothing.
And I apologize, Amir, for not getting to you. I was fearing that we were going to be running out of time, and I think that question will definitely push us over as we go through the setup. So I will make sure to reach out to you right after this, if that's fine with you. All right. So we're not having any more questions. Looks like we've satisfied everybody's hunger for composites knowledge today, and we'll let you guys get back to what you're doing. So I appreciate everybody coming.
Thank you, Dean.